Hello all. Today we are discussing about OData in SAP. Here we are introducing the OData architecture and steps to create an OData service. What is OData? It is a standardized REST-based protocol for creating and consuming data APIs. It allows communication between SAP systems and external applications. It is based on standard web protocols HTTP and HTTPS and formats data in XML or JSON. OData enables smooth, secure, and efficient data exchange, making it ideal for SAP Fiori, SAP UFI, mobile applications, and third-party integration. Before we start creating the OData service, let's understand what we are going to do. Here I am creating a custom sample OData service to demonstrate OData project creation, metadata concepts, and cache cleanup. As a part of this example, we will use a purchase order scenario and create two entity types, PO header and PO item, along with their corresponding entity sets. The PO header entity type acts as a blueprint that defines the overall structure of a purchase order, including fields such as PO number, vendor, company code, and document date. The PO item entity type represents the individual line items of the purchase order, such as material, quantity, and price. With this understanding in place, let's move ahead and start creating our OData service step by step using the SEGW transaction. So let's go to transaction SEGW, click on create project and enter the project name SAP_OData and give the meaningful description, purchase order details, and click on local object and also click on save button. Next step is to create entity type. An entity type in OData is a data structure that represents a business object like a table row and contains its fields, properties. Here we can create an entity type in different ways, either manually or based on a structure. Now let us start with option 1. In this option, we create an entity type manually. First go to the data model, right click on the entity types, select create and give the name PO header, which represents purchase order header data. And below you can see there is a checkbox. When this checkbox is selected, it will create entity sets. But I am skipping and I will show in the creation of this entity type. Next we add properties. Properties are the fields of the entity. Set EBLN as the key field. EBLN uniquely identifies a purchase order. Now add other fields. BUKRS for company code, Listener for vendor number, BDate for document date, and set the idiom.core type as idiom string for the all properties. Since we are creating the entity type manually, there is no predefined structure involved. Once all properties are added, click on the save button and the entity type is ready. Now let us move to the next entity type using option 2. In this option, we create an entity type using a DDA structure for purchase order item details. Select data model, right click on the data model, select import, choose PDD structure, and now give the name PO item. Next enter the above structure name EKPO. Here the entity is created based on a specific DDD structure. Make sure the entity set option is selected. This will create the entity set automatically. And click on next button. Now select only the required fields, that is EBLN, EBLP, Matner, MENG. And set EBLN as the key field and click on finish. Now go back to the properties of the entity PO item. After creating all properties, there are checkboxes with each respective property. Let's know about them and how it will behave. Is key marks the property as the primary key of the entity type. Without a key, entity set cannot be created. Keys cannot be nullable. Nullable. If checked, property can be empty. If unchecked, value must be provided. Creatable. Allowed to send this field in a create or post request. If unchecked, field is ignored during create. Updatable. Allows the property to be updated in foot or patch. Filterable. Field can be used in $filter process in OData. Sortable. Field can be used in $order by. Precision or scale. These are not checkboxes but important. Precision means total number of digits. Scale means digits after the decimal. Max length. Define maximum characters for string properties. The checkboxes changes how the properties appears in the metadata and decide how the service should behave during HTTP operation and query operation, and also validates a SAP gateway framework. Example, if a non-creatable property is sent in post, gateway rejects it. Next step is to create entity sets. An entity set is a collection of entity type records, like a table. Now let us create entity sets. Right-click on the entity sets, choose create, and give the name PO header set, and choose the entity PO header. And click on the save button. After creating the entity types and entity sets, the next step is to generate runtime objects. Now select the project and right-click, choose generate runtime, or you can also click the generate runtime objects button at the top and click on continue and click on local object, and the system will automatically create the required base classes and extension classes for the OData service. These generator classes are grouped and displayed under the runtime artifact section. So let's know about the idea about base classes and extension classes. First, go through the base classes. Model provider class, MPC. MPC defines the structure of the OData service, which is the metadata. The gateway checks this metadata through the define method. It checks whether filter fields like buick errors are valid and also ensures that data types are correct. Data provider class, DPC. DPC defines the runtime behavior of the OData service. It contains the business logic, and it fetches and processes data using above code. Next, go through the extension classes. MPCXT, Model Provider Extension Class. It is used for custom metadata definitions, and it allows us to enhance the $metadata without losing standard changes. DPCXT, Data Provider Extension Class. Here we implement the get, post, put, and delete methods to fetch data from database table, and to validate input data, and to map above data to OData searches, and to modify the response. So now let's register the OData service in the Gateway Hub to make it available for testing and external access. For this, copy the registered service from the runtime artifacts and go to transaction/iwfnd/main_service and click on add service. Select the system alias as local. Then enter the technical service name as registered service, which is copied from the runtime artifacts, and enter. Select the line and click on add selected services, and finally assign a package or choose local object to complete the registration. Now the OData service is successfully registered. The final step is to test the OData service. Once the service is activated, you can test it by selecting the service in this transaction and clicking the SAP Gateway Client button. When you click this button, the system will automatically navigate to the SAP Gateway Client screen, where we can test various OData operations such as get, post, put, and delete, and verify the service responses. Alternatively, you can also test the OData service directly by using the transaction code /iwfnd/gw_client. This approach allows you to access the gateway client independently without going through the service maintenance screen. You can choose whichever method is more convenient and best suited to your workflow for testing the service. Now select the URI option by clicking on the Add URI option button and enter $metadata. Then execute it to view the service metadata, which provides a complete overview of all available entities and their structure. In SAP OData, metadata is the complete technical description of the OData service. It defines the data model created in SEGW, including entity types, entity sets, properties, keys, associations, and relations. SAP Gateway stores metadata and model information in cache to improve performance. Because of this catching, sometimes recent changes are not reflected immediately. For example, when we add a new entity or property in a SEGW, or when we change the structure, or adding annotations, or updating logic in MPC or MPCXC, or adjusting the service implementation. The gateway or frontend may still display old metadata, old structures, or incorrect values. To fix this, we need to clear the metadata cache. So let's know how to do the metadata cleanup cache. At the top menu, select metadata, then choose cleanup cache. After cleaning the cache, the latest changes will be reflected correctly. So to conclude, in this video, we understood the concept of creating a purchase order data project in SEGW. This kind of basic project is very important for beginners because it helps us clearly understand entity types, entity sets, and metadata before moving to complex scenarios with multiple entities and associations. In the upcoming videos, we will move from concept to implementation and see step by step how to build this purchase order data service in SEGW, including entities, associations, and backend logic. Thank you for watching and see you in the next video.